Hello everyone. The title of my thesis is Design and Optimization of Big Data Connection Algorithm based on Data Redundancy Technology. The thesis mainly involves the following contents. 1. Introduction to Research on Design and Optimization of Big Data Connection Algorithm based on Data Elimination Technology. 3. Design and Optimization Research Experiment of Big Data Connection Algorithm based on Data Elimination Technology. 4. Design and Optimization Research Experiment Analysis of Big Data Connection Algorithm based on Data Elimination Technology. 5. Conclusions. 1. Introduction. In the 21st century, when computer technology and information technology continue to accelerate development, information has become an indispensable part of life. 1. 2. All sectors of society rely more and more on the information industry, and information data is also showing an explosive increase. There is a large part of redundant data in these growing data. How to deal with these redundant data and reduce storage resources. The waste of data and the difficulty of data query have become an urgent problem that enterprises need to solve. 3. 4. In relational databases, connection operations are the most common and the most difficult to implement. 5. The join operation is a very important operation because it can merge two data tables with the same attribute value. 6. Therefore, it is worth studying to effectively optimize the redundancy and connection of multiple data sets, and it is a very meaningful research direction. Among the many big data researches, some of them are researches on connection algorithms. For example, Wencai and Wencai proposed an improved self-join algorithm based on MapReduce by analyzing the self-join redundancy in self-joining of current similar joining algorithms, and the complexity of reading original strings. Adding filtering conditions in the filtering stage of the improved algorithm can eliminate its own redundancy. In the verification phase, the redundancy techniques such as positive and negative candidate pair generation and combined ID are used, and the data set only needs to be read once when reading the original string content. This article introduces the basic concepts and methods of data redundancy technology, introduces various classification methods, and analyzes and compares them. In this article, we describe the redundancy deletion algorithm from two aspects: improving the redundancy deletion rate and deleting the redundancy rate of the redundancy deletion system. This paper innovatively proposes a parallel hierarchical redundancy elimination algorithm (PhD), which not only improves the data redundancy elimination rate, but also increases the redundancy elimination rate. This paper proposes an optimization strategy for index-based partition joins for the connection method of two data tables. This paper improves the connection method of reduce side based on the idea of map side connection. When the join operation is performed in the map phase, the reduce phase can be reduced, thereby eliminating the shuffle phase and improving efficiency. 2. Research on design and optimization of big data connection algorithm based on data elimination technology. Data redundancy technology overview. Data redundancy technology is the process of reducing or deleting redundant files, bytes or data fragments, thereby ensuring that only unique data is stored on the disk. 8. Data redundancy technology is an emerging technology in the storage field. It uses the same or similar data function between files or between files, and automatically meets the requirements of using special calculation methods to automatically search and extract redundant data. Once the original redundant data is deleted, the data obtained is unique, so the data space occupied by the actual storage medium will be reduced, and the virtual space of the storage space can be realized. 9-10. Classification based on the granularity of eliminating redundancy according to the size of the deduplication resolution. Data redundancy technology can be divided into complete file deletion, fixed length block deletion, variable length block cancellation, and byte level cancellation. The advantage of deleting complete files is that the calculation speed is very fast. When processing a large number of files, all the same files can be detected, thus saving a lot of storage space. The advantage of eliminating fixed length block redundancy is that the algorithm is simple, the calculation speed is faster, and the data redundancy elimination rate is higher. The advantage of this variable length block deletion method is that it can effectively deal with file insertion and deletion problems, and can detect more redundant data than required. The advantage of eliminating redundancy at the byte level is that the redundancy elimination rate is relatively high, but it requires a large number of search operations, so the redundancy elimination rate is relatively slow. 11-12. Classification based on the execution order of redundancy elimination according to the time to implement redundancy elimination. It can be divided into online redundancy elimination and redundancy elimination post-processing. Online data redundancy is about eliminating data redundancy before writing data to disk. The biggest advantage of this processing method is that it is cost-effective and does not need to store redundant data sets that will eventually be deleted, thereby reducing the need for storage capacity. Post-data redundancy, also known as offline data redundancy, is the process of eliminating data redundancy after writing data to a disk. Since data redundancy is performed on a separate storage device after storage, this will not affect the entire business process, and a redundancy implementation plan can be made in the data as needed. Parallel level replacement and elimination algorithm. Redundancy elimination algorithm. The CDC algorithm is based on the content of the file and uses rabbi fingerprints to divide the file into data blocks. This is a flexible block deletion method designed to understand that long blocks are sensitive to operations such as file insertion and deletion. Hierarchical HD algorithm for eliminating redundancy. The specific implementation of the hierarchical elimination of the redundancy elimination algorithm is to first use the CDC elimination algorithm to eliminate the redundancy at the data block level, and then use the set compression algorithm to eliminate the byte level redundancy. After the redundancy level is eliminated from coarse to fine, a large amount of redundant data can be effectively deleted to obtain a better deduplication rate. Parallel hierarchical redundancy elimination PhD algorithm. The parallel hierarchical redundancy elimination algorithm is realized by introducing parallel computing on the basis of the hierarchical redundancy elimination algorithm. The core idea of the PhD algorithm is to use multi-threaded concurrent processing of data blocks and data encoding compression in hierarchical redundancy elimination, which will reduce this part of the time overhead and increase deduplication under the premise of higher deduplication rate. MapReduce working principle. In the map phase, the input file is sliced first, and then the sliced result is passed to the mapper node, and then the key value pair after slice analysis is passed as an input parameter to the user-defined map function. After the map function is processed, the output is intermediate the result key value pair. After executing the mapping function, sort the intermediate result set, divide it and send it to the reducer node. In the reduce phase, each key value pair returned by the map is passed as a parameter to the user-defined reduce function. And after the logical calculation of reduce, the result is finally obtained, and output to HDFS. Job execution process job submission and initialization. Start a job on the client, and make a request to the job tracker. After the job tracker receives the request, it will assign a job ID to the requested job. At the same time, the client also needs to submit the job information to the job tracker. Task scheduling and monitoring. Task tracker that performs the task will periodically send a heartbeat to the job tracker to inform the job tracker that it is still running. Preparation of task operating environment. Preparation of the operating environment includes JVM startup and resources and isolation, which are all implemented by task tracker. Task execution. After task tracker prepares the running environment for the task, it will start the task. The job is completed. After all tasks are executed, the entire job is executed successfully. Connection query processing technology based on MapReduce module connection algorithm. On the reduce side, the reduction edge connection method is one of the simplest connection methods. The main design idea is, in the map initialization phase, read all the source data uniformly. The key value output by the map is the value corresponding to the join field, and the output value is the value of each record. For each field value, in order to accurately distinguish the data source, you need to add an identification value to each field. Compared with ordinary MapReduce tasks, the value of the map output during the join operation is more marked with a tag. In the first stage of reduce, the reduce function needs to obtain the value list corresponding to the source label key, and group the value list according to the source label, and finally perform the Cartesian product on the input, which means that the actual connection operation can be performed in the reduce second. The stage begins to execute. Connection algorithm on the map side. In the connection algorithm on the map side, there is only the map phase, and there is no reduce phase. The larger data set is used as the input of the map task, and the smaller data set will be copied and entered into the memory of each map task node. The connection of each table can be completed in the map phase, so the data transmission between map and reduce can be reduced. Index-based partition connection optimization and design partition strategy. The principle of partitioning is that the partition should be able to be loaded into memory. There may be two goals to consider for the size of the partition here. First, a partition size can ensure the best connection performance, and secondly, the partition threshold can ensure that the partition connection can perform better than the connection algorithm based on the reduce side. There are several factors that should be considered when calculating the threshold of the partition. In the formula, 1 reflects the map task running at the same time, reflects the size of the largest data set, is the size of a split file, and is the capacity of the map task. The number of simultaneous loading of multiple tasks on a node is similar to the partition result of all running partition tasks, and the number of nodes. In order to put all the partitions into the memory at the same time, it must ensure that the partition size and the number of running map tasks are smaller than the physical memory of the machine. This restriction is expressed in equation 2. Index level. Indexes mainly include two types in the sort file. One is dense index, which can index the records in each table. The second is sparse index, which can build an index for a group of sorted records. The appropriate storage method for index files is dense index. In HDFS, we use two levels to store index files. The index level of the data table. At the top level, there is a global index and a directory of partition files. Under this directory, there are many partition files corresponding to the data table. For each logical partition file, there is an index storage, the logical partition ID and the location of the logical partition, stored in the physical partition file. Free design and optimization research experiment of big data connection algorithm based on data elimination technology redundancy algorithm simulation simulated environment. The algorithm is implemented in Java language simulation, using Eclipse development tools. The experimental machine operating system is Windows 10, and the memory is 8 grams. Simulation method design. Apply the redundancy algorithm to the OFID tag to test the performance of each redundancy algorithm, and select the appropriate redundancy algorithm. Suppose the label set is S, the total number of labels is N, and the redundancy rate PD. The number of effective labels is N, 1 PD. The number of redundant labels NPD. Each tag is inserted into the tag set S at a random position of 1 N, and the effective tags and redundant tags are randomly distributed. Change the number of tags N, and compare the time cost and the redundancy rate, and the misjudgment rate of the redundancy algorithm within the specified time window. Connection algorithm optimization experiment test experimental environment. This article uses Hadoop's implementation of MapReduce connection query as the main optimization object to study. Therefore, in order to prove the superiority of the algorithm, it is necessary to build a Hadoop cluster. The Hadoop cluster, in this article, is composed of 12 PCs. One of the PCs is used as the nemenode node, and one of the PCs is used as the secondary nemenode to serve as the backup of the nemenode. Once the nemenode has a problem, the secondary nemenode can be used to ensure the normal operation of the cluster, and the remaining 10 are used as the datanode. On the other hand, one of them is used as job tracker, and the remaining 11 are used as task tracker. For unified management, nemenode and job tracker are the same node. For each PC in the Hadoop cluster, the memory size is 8 GB, the hard disk is 2 TB, and the CPU is a quad-core processor with a frequency of 25 GZ. The operating system is CentOS 6.4, the JDK version is 1.8, and the Hadoop software version is 2.6.5. The default data block size is 64 MB, and the copy assignment factor is 3. Experimental data. The experimental data comes from the open source TPC-DS dataset. TPC-DS is a standard developed by the TPC organization for testing the performance of OLAP database management systems. It contains 7 fact tables and 17 latitude tables. On average, each table contains 18 columns. The table can be set according to the scale factor SF, and its data volume can be set from 1 GB to 1 TB. Connection experiment. In Hadoop's reduce side connection implementation of MapReduce, the map side will send all key value pairs to the reduce side, including some useless information, which will cause a lot of time overhead in the shuffle phase. In response to such shortcomings, this article provides an index-based partition connection optimization algorithm, which implements all the connection operations on the map side, eliminates the reduce side, and reduces the cost caused by the shuffle stage, and according to the index to fetch as needed, to avoid the loading of useless information. 2 tables connection experiment. In the experiment of the 2-table connection, the 2 data tables catalog_sales and store_sales in TPC-DS are used for the experiment, because they are the largest data tables with primary and foreign key associations. In order to test the performance of the partition connection, there are 5 sets of data of different sizes. Multi-table connection experiment. In the connection of multiple tables and multiple attributes, this paper uses 2 sets of experiments to prove the effectiveness of improved partitioning. Experiment with a connection of 3 tables and 6 tables respectively. First, in the 3-table connection experiment, this article selects catalog_sales, store_sales, and web_sales 3 tables to connect, and pulls 5 different sets of data from TPC-DS. Secondly, in the experiment of connecting 6 tables, this article selects catalog_sales, catalog_return, store_sales, store_return, web_sales, web_return 6 tables to connect, and selects 5 sets of different data from TPC-DS for testing. For design and optimization research experiment analysis of big data connection algorithm based on data elimination technology redundancy algorithm simulation under the condition that the redundancy rate is 60%. The comparison of the redundancy time and the redundancy rate of PhD, HD and CDC algorithms is shown in Table 1. It can be seen from Figure 1 that when the redundancy rate is set to 60%, the time consumption of PhD is about 1/3 less than that of CDC, which is not much different from the consumption of HD algorithm, and has higher performance. In the specified time window, when the redundancy rate is set to 60%, the hierarchical redundancy algorithm is better than the existing algorithm, in terms of the redundancy rate. The above results show that PhD is more suitable as a data filtering process of big data connection algorithm. Connection algorithm optimization experiment test 2 tables connection experiment analysis and the 2-table connection experiment. In order to test the performance of the partition connection, 5 sets of data with different sizes are generated. The data size and the time spent are shown in Table 2. From Figure 2, it can be seen that the running time of the partition connection is 2/3 of the reduced side connection. This advantage becomes more obvious when the size of the data set increases. The above results show that the partition connection performs better than the reduced side connection, which can effectively reduce unnecessary time consumption caused by shuffle. And when the partition connection algorithm is used, some files will be loaded into the memory of the data node. The memory utilization of the node will increase. 5 Conclusions. The advent of the big data era brings people the diversification of information and the completeness of data. Effective integration and analysis of these large-scale data can obtain useful academic or commercial value from it. As a common operation, connection operation is widely used in big data distributed processing and calculation. However, due to the multi-source, large-scale and high redundancy rate of data, it has become a challenge to realize connection operations under big data. MapReduce is a popular distributed computing model that is easy to use, highly fault-tolerant and highly scalable, and has been recognized by most users, and is widely used in big data processing and calculations. In the connection optimization strategy of MapReduce, a connection strategy based on index partition is proposed. Finally, 5 sets of TPCDS data are used in the experiment to prove that the optimization method can perform the task of connecting 2 tables better than the traditional connection method. Thank you.